Hey everybody, welcome to Conceptual Geometry, Lesson 3.2, more properties of a parallelogram. So just a quick review from the last lesson. We talked about the properties of a parallelogram, opposite sides being equal, diagonals bisecting each other, opposite angles being equal, adjacent angles adding up to 180. What we're going to focus on today, we're going to talk about the opposite sides quite a bit being equal. We're also going to talk about the diagonals bisecting each other, as you can see in this diagram here. Those two will be equal, and those two segments will be equal as well. So let's get right into it. Example 3. It says, in parallelogram x, w, y, z, if wx, all right, so where's wx? Right here, is 5x plus 14, and zy is 7x minus 24, find wx. All right, well, it's a pretty simple observation. These are opposite sides. It's a parallelogram, so these two are going to be equal. Let's just set that up quickly. 7x minus 24 equals 5x plus 14. I'm going to subtract 5x from both sides. And while I'm doing that, I'm going to add 24s. I need 24 to be on the right side. 7x minus 5x is 2x. And 14 plus 24 is 38. Divide both sides by 2. And x equals 19. Now remember, we're not done when we get 19. I want to find wx. So I need to plug that in here. All right, wx equals 5 times 19 plus 14. I would just throw that right into the calculator. 5 times 19 is 95, plus 14, I believe, is 109. Next example. Again, we have a parallelogram. This time it's giving me ZV. So that's a part of the diagonal, ZV. Y plus 11. So again, it's important to remember I'm just talking about this length here. Then it says VW. All right, VW is this piece. Well, that should be easy then because that's going to be equal. Is 3y minus 17. And that's that piece. The property to remember here is that the diagonals bisect each other, so these two pieces are equal. Simple equation, 3y minus 17 equals y plus 11. I'll subtract y from both sides. At the same time, I'm going to add 17. 3y minus y is 2y. 11 plus 17 is 28. Divide by 2. Y equals 14. What's the question I want you to find? ZW. Well, we got to be a little bit careful here. ZW is the whole thing. So there's a couple ways you can do this. One is you could add these two pieces together, figure out what that algebraic expression is, then plug in the 14. Or what I'm going to do, I'm going to plug in 14 here. So that's 14 plus 11, that's 25. So if just this piece here is 25, and I want to find ZW, I just need to take 25 times 2. Now, it should not matter which way you do this. You'll end up with 50 regardless. All right, another parallelogram question here. This time, it tells me WY. So WY is this side. 14 minus 3x. Okay, that's this side here. XZ, well, that's this side, is x minus 2. Again, I'm hoping it's pretty obvious. Opposite sides, they're equal. I just have to set those two equal. The algebra here is a little bit interesting. I think that's probably the focus of this problem. What's a little bit different, we haven't seen it a lot in this course, is I have a negative x on this side. Now, you don't have to do this. I just like getting rid of that negative x. I'm going to add 3x to both sides. So I'm moving my x over to the left side, which means then I'll have to add 2 to both sides. So x plus 3x is 4x. 14 plus 2 is 16. Divide by 4. X equals 4. What we're going to see a lot in this unit is not just solving for x, but finding a particular angle or a side. So find WY, that's this side here. Well, I'll tell you what, it doesn't matter. Since these are equal, to me, that looks more difficult to substitute into. You could do it, but that's pretty easy. So if I want to find WY, I know that's the same thing as 4 minus 2 or 2. Again, I just plugged it into this expression. You could have plugged it in here. 3 times 4 is 12. 14 minus 12 is 2. You get the same answer. It just might take you a little bit longer. Both are correct, however. All right, our last page of notes. These will be the most challenging for a couple reasons. Number one, I don't see a diagram anymore. So we're going to draw our own diagram. Parallelogram LMNO. So you can get a lot of practice drawing these parallelograms. It's a skill in and of itself. Now, when it comes to naming these, here's what's important. You have to go around in a circle. So I don't care where you put an L. I can put it here, 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 here. That doesn't matter. But wherever you start, then the other letters have to go in order in one direction or the other. So if I start with L here, I have a choice. I can go M, N, O, or I can go this way, L, M, N, O. What you can't do is left to right, or up and down, up and down. It has to be in a circle, all right? I know I'm taking a long time explaining this, but it's very important. So L, M, N, O. It says an exterior angle at vertex O. So it's kind of convenient. I put it at the bottom. There's an exterior angle. So we need to extend a side out. Measures 72 degrees. Find the measure in degrees of angle L. That's going to be my X right there. All right, well, this isn't really that hard. There's a couple things that we can do. Number one, probably the easiest, and I told you guys we're going to see this section of the diagram over and over again all year long. This is a straight line. That means this angle here and that angle there are supplementary. So to find this one, I'm just going to take 180 minus 72. That's 108. Now, in a parallelogram, the adjacent angles add up to 180. So to get that angle there, I take 180 minus 108. Well, guess what 180 minus 108 is? 72. And the reason it works out like that is because if you think about it, we've got parallel lines. So if I extend those through like so, and then here's my transversal, oh, remember we said all the acute angles are going to be equal. So all four of these angles are equal. So if this is 72, that's going to be the same thing. Next example, two angles of a parallelogram are in the ratio 3 to 7. So I need to draw a parallelogram. Now notice this one does not give you the letters. And it says two angles are in the ratio of 3 to 7. So remember what we do. We make one a 3x, we make one a 7x. Well, how do you know where they go? Well, the key is to understand the opposite angles are equal. The adjacent angles add to 180. These clearly are not equal. So one's going to be the acute angle, one's going to be the obtuse angle. Obviously 3x is smaller, so that'll be the acute angle. 7x is bigger, that'll be the obtuse angle. The equation is really simple. 3x plus 7x, I'm actually going to do it right here, equals 180. Combine those, I get 10x equals 180. Divide by 10. X equals 18. The question wants you to find the smaller angle. Well, that's 3x. 3 times 18 equals 54 degrees. You can put it in the figure if you wanted, or you can just circle it down here. And finally, our last example. Parallelogram ABCD. So again, just to emphasize this point, you have to go around in a circle. So you could start here and go around this way if you want. You could start here and go around that way. It doesn't matter. Wherever you start, just keep going around in a circle. I usually start at the bottom and go clockwise. A, B, C, D, but you don't have to. AB is a side. AB is this side here. That's 5x minus 4. Use a different color to highlight that. That side, 5x minus 4. CD is this side. It's 2x plus 14. Well, opposite sides, they're equal. 5x minus 4 equals 2x plus 14. I'll subtract 2x from both sides. So I'm moving the x to the left. Means I have to add 4 to move that to the right. 5x minus 2x is 3x. That's 18. Divide by 3. X is 6. And guess what? Find the value of x. Awesome. I'm done. All right. Great job, everybody. That concludes day 2. You can move on and do Delta Math Homework 3.2 now. As usual, if you have any questions, don't hesitate to reach out. Thanks for watching.